Okay, boys and girls, yesterday we used our place value discs on a unlabeled place value chart to help us subtract in vertical form. Today we're going to draw a chip model to help us subtract in vertical form. So I'm going to go ahead and tilt down my camera so that you can see my personal whiteboard. And I'm going to write today's problem. Let's go ahead and read today's problem together. 31 minus 18. Nice job, boys and girls. So as we look at this problem, I'm going to ask you this question. What is our whole? Oh, I hear lots of people saying 31 is our whole, and that's correct. What is the part that we know? That's right, 18 is the part that we know. So what are we trying to find? I hear lots of people saying the missing part. That's correct. We are looking for the missing part. So I'm going to go ahead and draw my place value chart. And because I will be using a chip model today, I know I need to label this place value chart. So this is my hundreds. This is my tens. This is my ones. And when we subtract, we know we only represent the whole in our chip model. So let's go back to the problem. What was our whole? That's right, 31. So I'm going to represent 31 on my place value chart, and as I do so, please count with me. 10, 20, 31. Nice job. So now looking at our chip model, how many tens and how many ones do we have? That's right, we have 3 tens and 1 1. We want to look very carefully at the whole when we subtract. And like a detective, we want to find out whether or not we need to do any unbundling. So I'm going to go ahead and draw an imaginary magnifying glass around my whole, which in this problem is 31. And we're going to start by looking at the smallest place value, which is the ones. Can we take 8 ones from 1 1? Oh, I hear lots of people saying no. So I want you to take a moment to talk to your shoulder partner. What should we do? Oh, I hear lots of people using place value language. I heard some of you say we can decompose a 10, and I heard others say we can unbundle a 10. Is that the same thing? Yes, it is. So let's go ahead and show how we can unbundle a 10 in our chip model. So we're going to go to our 10s, and we're going to unbundle. And as I unbundle this 10, please count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we do to our chip model, we also have to show in vertical form. So let's start in our tens. We no longer have 3 tens because we unbundled 1 10. So we need to rename our tens. So how many tens do we now have? We now have 2 tens. And because we unbundled that 10, how many ones do we now have? That's right, we now have 11 ones, so we need to rename our ones. Does our chip model show the same thing as vertical form? Yes, so now we're ready to subtract, and we're going to start in our ones. 11 ones minus 8 ones. So let's show that on our chip model. We have 11 ones, and we're going to take away 8 ones. So how many ones do we have? That's right, 2 ones plus 1 1 equals 3 ones. So let's show that in vertical form. Now let's look at our tens. 2 tens minus 1 10. So we have 2 tens on our chip model. We need to take away 1 10. How many tens do we have? That's right, 110. Let's show that in vertical form. So what is our answer? That's right, 13. Because we can go back to our learning from kindergarten and first grade. We know if we have 110 and 3 ones, we have 13. Nice work, boys and girls.